Okay, so here we're going to try and formalize the hypothesis testing strategy. Firstly, there are 8 key points that you want to make sure you include in every single hypothesis test, and these are listed on the right hand side for you. So we'll make a start. I always like to start by stating exactly what the discrete random variable is. X is the number of heads achieved. Next, we'll set our hypotheses. H0, the null hypothesis, is that everything's normal. Everything's as you would expect. So the probability of getting heads is a half. The alternate hypothesis, this is where a claim has been made that the coin is actually biased towards heads, which would mean the probability of achieving heads is actually larger than a half. So my null and my alternate hypotheses. From there, we always want to state the distribution. So x follows a binomial, and we'll put the values in, and we'll say what the expectation is. Once I've got the expectation, I like to draw a quick sketch just to clarify in my head and in yours exactly which region we're going to be calculating later on. So the expectation is roughly in the middle, so I'll just put that on this rough sketch. The binomial distribution doesn't look like this, but it's just for us to get a good picture in our heads. The significance level, the suspicion level, this is usually given to us in the question, so we'll write that down as alpha. So alpha equals 0.05 for 5%. Okay, next calculating the test statistic. We were told in the question that there were 6 heads. So I know I'm working out a probability based around the number 6. Am I going for greater than or equal to 6 or less than or equal to 6? Looking at the diagram again, we see that I should be going even more extreme than 6. So that means I'm going towards the right hand side. I'm trying to make sure I avoid the expectation. I should never include the expectation in this test statistic probability. So the probability that x is greater than or equal to 6, I can calculate, and that ends up being 0.1445. Now this is larger than my significance level. This is quite a big probability. I don't have any evidence to reject H0. I'm going to make that comparison, and I'm going to make that first conclusion, which is a mathematical conclusion. There is not enough evidence to reject H0. The second conclusion to make is in context. Well, this is all about a coin and whether or not the coin is biased. So I can also say there is not enough evidence to suggest the coin is biased. Okay, so I'm not rejecting H0. I'm not rejecting that the probability is a half. So I'm not rejecting that the coin is fair. There's alternate ways to say the same sentence. Just choose one that's concise and clear. Okay, so let's try another one. This one has just a little bit more going on and there's some more context to get through. Okay, standard treatment for disease has 2/5 probability of success. A doctor has undertaken some research in this area and has produced a new drug which has been successful with 13 out of 20 patients. The doctor's claim is that a new drug represents an improvement on the standard treatment. Test at a 5% significance level the claim made by the doctor. So as usual, I'm just going to start off with describing the discrete random variable. So X is going to be the number of patients for which this new drug is successful. From here, I need to choose my hypotheses. The null hypothesis, everything's normal, there's nothing special going on. Well, that means the new drug is exactly the same as the old drug and has a probability of success of 2/5. The alternate hypothesis, that the doctor's claim is correct, would mean the new drug has a probability of success that is greater than 2/5. So here's my null and my alternate hypothesis. Okay, we're working with the binomial. N is 20, there are 20 patients being used, and we can find our expectation by multiplying N by P, and that gives us 8. Quick sketch, as I've always asked you to do. 8 is the expectation, it's in the middle. It's going to help us to calculate the test statistic probability correctly. Significance level was given in the question of 5%. So 13 were successful. So just quickly on the sketch, I realised I should be going for greater than or equal to 13, and that probability on your calculators 0.0210. Is that enough for me to be suspicious? Is that a significant result? It's less than the significance level. It is a significant result. There is enough evidence to reject H0. So there is something strange going on. We are suspicious of whether or not the probability is 2/5, and we can conclude there's enough evidence to suggest that the doctor's right. This new drug does have an improvement on the standard treatment. Or this new drug does represent an improvement on the standard treatment. When you're writing the contextual conclusion, it's really a bit of copy and paste from the question. Try and use exactly the same phrase that was given to you in the question. So the doctor claims the new drug represents an improvement on the standard treatment. That phrase should appear in that final conclusion. And here we've hit all of those 8 steps to get full marks for a hypothesis testing question. Okay, and I'll do one more with you. This one needs a little bit of intuition to make sure you respond to it correctly. So the students are doing a multiple choice test. There's 10 questions, each with 5 possible answers. Test with a one-tailed test at a 10% level of significance whether or not the teacher's claim is correct. The teacher claims that the student is just guessing the answers. So the random variable, X, is the number of questions answered correctly. The null hypothesis, well, if the student is actually just guessing, the probability of them being correct is 1 out of 5. It's 5 possible answers. They chose one of those 5 answers. If they weren't guessing, if they actually studied for this test, we would expect the probability of them getting a question correct to be above 1 over 5. So for them to be quite likely to respond correctly if they'd studied for the test ahead of time. So this time round, the teacher's claim is actually the null hypothesis. So just make sure the context is clear in your head. Which one is the claim of the teacher, the manager, the worker, the scientist, whatever it is. Okay, so moving on. Let's just get the distribution down. So it's a binomial distribution, n equals 10, probability of success is 1/5, expectation is 2. If someone was guessing, you would expect them to get 2 answers correct. Okay, 2 is my expectation. I'll put it in the middle of my quick diagram. Well, this person actually got 4 questions correct. So we can see we're looking for greater than or equal to 4. The significance level was 10%, and the probability of greater than or equal to 4 is 12%. It's quite large. It's not enough to be suspicious. So we write down the comparison, and we draw our conclusions. So there is not enough evidence to reject H0. So actually, totally guessing and getting 4 answers correct is quite likely to happen. So maybe the teacher is correct that this student was guessing. There's not enough evidence to suggest otherwise. At the 10% level of significance, this student would have needed more correct answers for us to reject the claim that they were just guessing.